In this video, we're going to look at finding the volume and the surface area of spheres and hemispheres. Here's a picture of a sphere with a radius of r. A hemisphere is simply half of a sphere. If you want to think about a sphere in real life, a good example is a snooker ball. If we want to find the volume of a sphere, we can say that the volume will be 4/3 pi r cubed. This is given in the formula book in an exam. If we want the area, we can say that this is going to be 4 pi r squared. So this is a sphere, so just writing this down, that's our sphere. If we wanted a hemisphere, just jotting this down, hemisphere, we can say that the volume is going to be half of this. So we can say that's 2/3 pi r cubed. And we can say that the area, excluding the top, so if I cut this in half, just the outside rather than the top, the area is going to be 2 pi r squared. And if I included a top, of course we'd have a circle with a radius of r. We could say with a top it would be 3 pi r squared. As we know, the area of a circle is pi r squared. So these two are given in the formula book, and all we have to do is now use or apply them to the questions. So let's go ahead and work through some questions. We're asked to find the volume of the following containers. A sphere of radius 6 centimeters. So we want the volume. The volume of a sphere is 4/3 pi r cubed as given in the exam book. So the volume is going to be 4/3 pi multiplied by 6 cubed. 6 cubed is 216. So straight for a calculator with this. And one way we can do it is write 4/3 multiplied by pi, so multiplied by pi, and then we're going to multiply this by 216. That's going to give me 288 pi. This is what we call an exact answer in terms of pi, and we can see that that would be 905, and it would be centimeters cubed. So I'm rounding that to 3 significant figures and giving the correct units. So we can say that the volume is 905, and that will be centimeters cubed, correct to 3 significant figures. So just popping that on, you will be given a level of accuracy to aim at in the exam. If we look at the hemisphere of radius 5 centimeters, we can say that the volume is 2/3 pi r cubed. So all I'm going to have now is volume will be 2/3 multiplied by pi multiplied by 5 cubed, or 5 to the power 3, which is 125. So as an exact answer, we could say that the volume is going to be 250 pi divided by 3, and that would be centimeters cubed. We could of course write that. I've left it as an exact value. If you wanted to give it as a decimal answer, 250, our shift, we hit pi, we divide the answer by 3. It will leave it as this exact value, and it's 261.79 and so on and so forth. So if you wanted to round it to one decimal place, 261.8. So volume is equal to 261.8 centimeters cubed. As you can see with these, I'm writing them to different levels of accuracy. You should be told in the exam what to aim for. So that's looking at now at the volume. Let's look at the surface area. So on the first one, we'll look at the surface area. Just check that you are given the radius rather than the diameter. If you're given a diameter, half the answer, then apply the formula. So the surface area is 4 pi r squared. So for the first one, we're going to have 4 multiplied by pi multiplied by the radius squared, which is 36. So the area as an exact answer is 144 pi, and that would be centimeters squared. This is an area, remember. If you want to think about this now, going back to a snooker ball, it's all of the painted outside. That's it. That's the area on there. So let's look at what that is. 144 times pi. Pi is about 3.142, and that's going to give us 452. So I'll write that in, 452 centimeters squared, and that's given correct to 3 significant figures. So let's put that on, 3 significant figures. Let's now look at the surface area of the hemisphere. If you think of a bowl, then we won't have a lid to that bowl. If you think of cutting a snooker ball in half, we will of course have another surface area, and that will simply be the circle at the end. So if I drew now a hemisphere, what we've got is the bottom part, so this is going to be half the circle, and then of course we've got the top. We know that the area of a circle is going to be pi r squared, so what we're going to have is the circle, which is going to be equal to pi r squared, and then we're going to have plus the hemisphere, which is going to be 2 pi r squared, as the full sphere is 4 pi r squared. So we can say now that the area is going to be 2 pi r squared plus pi r squared, 3 pi r squared, and that is going to give us that will be 3 pi multiplied by 5 squared, which is 25. So the area is 75 pi, and that will be centimetres squared. That is what we call an exact value, and of course you can find that on the calculator as a decimal. So 75, we hit pi. If you've not got pi, 3.142, and that gives us 236 centimetres squared, correct to 3 significant figures, or 235.6 centimetres squared, correct to 1 decimal place. So that's with a lid. If you don't want it with a lid, you're only going to have 2 pi r squared. Okay, let's do another one. The ceiling of a church is in the shape of a hemisphere. If its radius is 8 metres, calculate its surface area. So we've got a hemisphere, so the area is going to be equal to 2 pi r squared. We're going to have the area is going to be now 2 lots of pi multiplied by 8 squared. 8 squared is 64. So the area as an exact answer in terms of pi is 128 pi metres squared. So if this was on a non-calculator question, you might leave that answer in terms of pi. 128, and then we'll have pi, and we can give that answer now as 402. So the area is equal to 402 metres squared, and that's correct to 3 significant figures. So nice and straightforward. Even if it's a bit wordy, just think now, what have we got and how can we use the formula? The diameter of the Earth is approximately 12,734 kilometres. We're asked to calculate its surface area. So what we've got here is the diameter. The radius is going to be equal to half of this. So I'm going to find half first. So we've got 12, and then we've got 734, and we're going to divide this by 2. That gives me 6367. So the radius is 6367 kilometres. So we want the surface area. We know that it's going to be a sphere, so we can say now that the surface area, A, you might see this being written as S, as the surface area. A is going to be now on here 4 pi r squared, so the area will be 4 lots of pi multiplied by this quantity of 6367 squared, and that's going to be absolutely huge. So with my answer now, I'm going to square this answer, and then I'm going to multiply this now, so multiplied by 4, and then we're going to have pi. So if I do that, it's going to give me that huge number right there, which looks to be 509,424,190, and that will be kilometres squared. So I'm going to write 509 million, and this is correct to 3 significant figures, and that will be square kilometres, or kilometres squared. So a nice big number there, but it kind of makes sense. It's a pretty big old Earth, so that's now the surface area. So if you wanted to sow grass on the whole of the Earth, that's how much you'd have to order in terms of the grass seed, which is going to be a bit costly. Okay, a piece of metal in the shape of a square base pyramid of height 10 centimetres and base size of 5 centimetres is melted down and recast into spheres of diameter 3 millimetres. How many spheres can be made? Okay, let's just look at this as a problem. The first thing I'm looking at now is that the diameter is 3 millimetres. So if I look at the radius of the sphere, so the radius is going to be equal to 1.5 millimetres. We're working now in centimetres here, millimetres here. So I'm going to write this in centimetres, and that will be 0.15 centimetres. You can, of course, convert this up into centimetres, or this one down into millimetres. It's entirely up to you. I'm now going to make an attempt to sketch a square base pyramid. So if we do that, a square base pyramid is going to look something like this. So let's go ahead and do that, and I'll just put these different sides on. So this is what we're going to have. Our square base pyramid will look something like that, and then we'll have that one just there. Let's put that one on, and we have now a perpendicular height. The perpendicular height is given, and I'll just put that on like so. So what we've got then is the base here. This is going to be 5, so that's 5. This is going to be 5, and this right angle perpendicular height is going to be 10. To find the area of this one right here, we can say that the area is going to be 1/3 the base area multiplied now by the height. So if we look at this, we're going to have 1/3 of the base area. Well, the base area is going to be 5 by 5, which is 25, multiplied by the height, which is 10. So we can say now that the volume, that we want the volume, I don't know why I've written area, we want the volume down here. Let's put the volume rather than the area, that makes no sense. The volume right here, let's put that here, the volume is going to give us that. So we can say that this is going to be 250 over 3. So volume is going to be 250 divided by 3, and that's given now as centimetres cubed. So let's now look at the volume of each of these. So the volume of each sphere is 4/3, then we're going to have pi, and then we're going to have r cubed. The radius is 0.15, which we need to cube. So let's go ahead and work that out. So I can put this in. And another way I can do this is now 4, then I can have pi in the numerator, and then I can have now the 0.15, so 0.15, which we can cube. Let's put that in and cube that. And then we can simply divide this by 3. That's giving me exactly the same. So that gives me now on here 0.014. So let's write this in, 0.014 ... So that is now the volume of each of the spheres. So if we take this volume, the 250 over 3, assuming there's no waste, and divide it by this number, that will tell us how many we can do. So let's go ahead and do that. So if you want to store this, Shift Store A, just in case you make an error. What we'll do is 250, so 250 divided by 3, and then we're going to now divide it by that answer. And that gives me now, my apologies, let's just get out there, divided by our value of A. Let's put in A, value of A, so we get 5894. So 5894, so 5894 spheres. We can't make the 5895th one, and that gives us what we want. Okay, so quite a nice question. All we're doing is looking at boiling that down and making some spheres. Calculate the radius of a sphere which has the same volume as a solid cylinder of base radius of 5 centimetres and height of 12 centimetres. Right, let's go ahead and just draw a sketch of this. Often a sketch helps. Let's just draw. Right, so this is going to be my cylinder. So let's just look at the cylinder, and we'll put that on. Our cylinder will look something like this. So we've looked at the volume of a cylinder before, so we'll make up the cylinder. Cylinder is going to look something like that. Okay, and with a cylinder, for the volume of this, we find the area of the cross section and multiply it now by the height. So what we can say then is the volume of a cylinder is going to be pi r squared. That is going to be the end plate multiplied by the height. So this is the cylinder, so the volume is going to be equal to the following. We're going to have the base radius of 5 multiplied by height of 12. So we're going to have pi, we'll have 25 multiplied by 12. And that's going to give me that the volume is 300 pi, and that will be centimetres cubed. So that now is the volume of the cylinder. If we think about the sphere is now 4/3 pi r cubed. So all I'm going to do is set these equal. So what I'm going to do, using therefore, that's the therefore symbol, 300 pi will be equal to 4, so all we're looking for is a radius. We need to solve for the radius. 4/3 pi, and then we're going to have r cubed. So at this stage, pi is just a number, so we can divide both sides by pi. So what I've got then is 300 is equal to 4/3 multiplied by the radius cubed. So if we multiply both sides by 3, that gives me 900, and divide both sides by 4, that is going to be equal to the radius cubed. All we need to do now to find the radius is cube root both sides of this equation, and we can say that it's going to be the cube root of 900 over 4. Remember, with the cube root, you're only going to have on this one a positive answer. So let's go ahead with a quadratic. If we got an r squared, we could have a positive or negative answer. And of course, when we're dealing with a length, a radius, it will be positive. So the cube root is the one just here. I just press shift, remember cube root, then put the fraction in, and we got 900 divided by 4. And that's going to give us 6.08. So we'll say now that the radius is going to be 6.08. That is given in centimetres, and that is correct to 3 significant figures. So quite a nice little question here. We're just simply using formulae and setting them equal to each other. Okay, we're asked to find the volume of the following shapes made up of cones, hemispheres and cylinders. So if we look at this one, now we have a radius of 6 and also a height of 6. This radius of course works for both the hemisphere and the cylinder. So if we do that, let's go ahead and look at that. What we've got then is the cylinder. If we start with the cylinder, so we've got the cylinder. The cylinder is going to be pi r squared height. So we can say the volume is going to be pi r squared height. So the volume is going to be pi multiplied now by the radius squared, which is going to be 36, multiplied by the height, which is 6. So as an exact value, we can say this is going to be 216 pi centimetres cubed. If I look at the hemisphere, so just writing this here, we've got the hemisphere. So a hemisphere is going to give me now, and instead of the 4/3, we're going to have 2/3. So 2/3 pi r cubed. So we got the volume is 2/3 of pi multiplied by 216. That's 6 cubed. So all I'm going to do is add these together. You can do that on a calculator, or you can simply add them. We've got 2/3 and a whole, so the volume is going to be 5/3 of pi multiplied by the 216. Feel free to do it on a calculator if you wish. If we got 216 pi and 2/3 of 216 pi, that gives me now a total of 5/3. So in a calculator, I'm going to write this, and if you've done it a different way, hopefully when we check our answers, they should be the same. Multiplied now, let's get out of there, multiplied by 216 pi. Loads of different ways you can write this, and that's giving us 360 pi, which is going to be 1130.97 and so on and so forth. So I'll say 1130, and that will be centimetres cubed, and that now is to 3 significant figures. So all I've done is put that in there. If we look at the next one, we've got a cone and we've got a hemisphere. When we look at the cone, the volume of the cone is going to be 1/3 pi r squared multiplied by the perpendicular height. So if we look now at the cone, this is the cone, so the cone, we're going to have the volume is going to be 1/3 pi, we're going to have r squared, which is going to be 49, that's 7 squared, multiplied by the height. Remember, this radius throughout the sphere, or hemisphere in this case, will be the radius of the base of the cone. So what's that going to give us now? Let's put that in a calculator. We're going to have 49 times by 11 times by pi, and we're going to divide that answer now by 3, and that's going to give us now 539 over 3 pi. So 539 pi divided by 3. I will leave it there for now. So that's the cone. If we look at the hemisphere, the good thing about leaving this is that I know that I can plug this value into the calculator and go from there. So with the hemisphere, so let's just write this here, we know that this is going to be 2/3 pi r cubed. The volume of the sphere is 4/3. This is 2/3. So we can say it's 2/3, and then we're going to have pi multiplied by 7 cubed. 7 cubed is going to give us, what, 343. Okay, so let's go ahead and just put that in the calculator. I'll just check that my brain isn't going nuts. 7 to the power of 3 should give us 343. There we go, and then we're going to multiply that by 2/3, and this will give us now the exact value. So we got 686, so let's write that in, 686 pi divided by 3. So all we've got to do now is add these two together, and we have our value. So if we do that, let's just do that. So what we're going to have then is the following. We're going to have now on here, and we can do this lots of different ways. Let's do 686 plus the 539. And if you wanted, you could put that, let's just put that over 3, and we'll just come back into here, and we can just put pi times by this amount. Loads of different ways that you can put it in. I'm not suggesting that's the best way. It's just one option for you if you're quite versatile with a calculator. So that's going to give 1283. So 1, 2, and that's going to be 1283, and that's going to be centimetres cubed, and that I'm going to give to the nearest integer. So nearest integer, nearest whole number, and write that there. Again, you decide on the level of rounding unless you're asked to do so. I like to do different things just to ensure we've got a bit of practice. Okay, let's do one more. Well, we've got a test tube. It's in the shape of a hollow cylinder and a hollow hemisphere. We're asked to calculate the volume of the liquid that can be held in the test tube. So this time we've got a diameter. We need to be a bit careful here. So if we've got a diameter, our radius is going to be half of that. We've also got this scenario right here, and this is 18.5. Now that's the whole length. So what I'm going to do, if we think about this now, this is going to have on here, let's put this on, this is going to be the radius. So the radius is going to be that length just there. Okay, let's go ahead and work this out. So what we're going to have is the following. This length, and we'll put this on, let's go ahead and do that. We'll put that height on. So this height right here is going to be the 18.5 minus 1.2. Hopefully you can see the logic behind that, because this length right here is the radius. So that's going to give me now 17.3. So we've got 17.3. So what we've got then is the following. We've got a cylinder, and the cylinder is going to have a radius of 1.2 and a height of 1.3. So the volume, and this is going to be the cylinder, so we'll say this is a cylinder, it's going to be now pi r squared height. So pi r squared height, the volume is going to be pi multiplied by the radius squared, which is 1.2, multiplied by 17.3. Okay, and we're going to now add to that the hemisphere. The hemisphere is given now, the volume is going to be 2/3, so we want 2/3 pi r cubed. So we're going to have the volume is 2/3 of pi multiplied now by the 1.2, which we need to cube. So all I'm going to do is add these two together. We need to be a bit careful here because we've got now the cylinder, and of course now this hemisphere on the end. So if we do that, I'm going to do this in one foul swoop, and we will just add it all up. So what I'm going to have is the following. I'm going to have now pi, so this is going to be pi, plus 1.2, which we need to square, multiplied by 17.3. And we're going to add to that now, so pi, let's multiply that rather than pi, multiplied by the 1.2. Let's do that, that looks a bit better. And then we're going to add to that now, on here, 2/3, so 2/3. Do check on the level of working required for your marks. 2/3, then we're going to have now pi multiplied by, let's put multiplied by 1.2 to the power 3. Again, with this one, you could factor lots of it if you wanted to do so. So let's check I've got all of that right. Pi times by 1.2 squared times by 17.3, and then we're going to add to that 2/3 pi 1.2 cubed, and that's going to give us 81.88 and so on and so forth. So I'm going to say 81.9. That is going to be now in centimetres cubed, and that is given to 1 decimal place. So be careful with those ones, split them up and then go from there. So that's a basic look now at finding the surface area of volumes and the surface area and the volume of spheres and hemispheres.